All right, here's another cool simulation like game that you could. I don't want to say game, but you could certainly get a lot of problems and discussion out of this particular idea. I guess you could make it a game. You could like see how many trials it took some of them to hit this target. Um, and you have lots of different like bells and whistles and things you can like change. It's nice that you can grab this and get a metric idea, time range, stuff like that. I didn't really get this thing to work very well for me, so I did mess around with the other things. It does have vectors involved. It'd be nice if you were going to do that. I can see how you could like use it in a situation where you could like talk about certain aspects of the math in certain classes, and then you could expand upon it over a course of like a couple years. Like you could like actually talk about this at the end of Algebra 1, and just talking about what happens when you just fire it. Okay, obviously that's some sort of parabola there with a restriction. You could measure the distances for a couple points. There's all kinds of good math that you could certainly use. If I move this around this way, we can like actually predict how tall things are. I can say, okay, that point was this particular height. Okay, I can mess around with like givens. There's lots of good stuff you can do with this simulator, and then cause good discussion to be had. It's not super easy to measure these things, but I mean you can like get it to be perpendicular eventually, and you don't want to like assume the numbers are nice. Now, that's just one like type of parabola. You could certainly give a bunch of different people. You could give one group three or four different like scenarios. Like, oh, that almost made it. So then you could have a discussion about like why that would have possibly happened. Um, if we're talking about the basic idea of projectile motion, that that your initial velocity has a lot to do with it. This has an angle of 0, so we don't have that extra like mathematics behind what the heck happens when we fire the thing at anything other than horizontal or vertical. This is more advanced than the like parachute problem we did in the Desmos activity, but you could see like what's going to happen here. So I'm gonna add like 1 mile an hour or meter per second in there and see if I can hit the target. And then I hit the target. Look, I get stars. Woo, great, wonderful. Okay, now the thing that I thought that was cool, other than like the fact that you can do all these things here, is it will let you chunk a lot of things. So these things, oh, they're very trivial. Very. I want to chunk a human and see if we can still hit the same target. Okay, now that human, it made its velocity, and I think 11 worked. So let's see if 11 works again. All right, it worked for the human. Okay, so but better than a human. What about a piano? Okay, we'd switch the piano to 11 and see if the piano can hit it. Look at that, I can get it with a piano. Now, we haven't talked anything about drag or any of these other things, but the novelty of being able to chunk a bunch of different kind of things is something that is like interesting. And look, it's still hitting it there. It's probably unrealistic that this cannon could shoot that thing, but it's cool. All right, now I'm allowed to move this target, which changes the scenario altogether. So I could give literally every kid in the class a different distance for the target, and then pre like I could pre-do the problem to see how they could actually get there. Now, I don't know. Let's see if we can even reach it by maximizing the initial speed of this cannon. Okay, I shot a car. Oh yeah, I definitely can. I can definitely hit it. Um, so I don't know. Let's back it down a little bit and see if we can hit that right there. Okay, still a little bit long. I like the idea that there's a bunch of like just totally destroyed 50 something cars there. It's something I think that kids would like to do. It's ridiculous, but anything to get them hooked is cool. All right, that would be considered a winner. Now let's see what some of these other crazy like buttons are going to do. So I'm going to turn on the total velocity vectors. Okay, it's got velocity in one direction. Okay, I'm going to put on the component vectors. I suspect that it's going to talk about horizontal projection and vertical projection. And it does. Put the acceleration vectors on there. And let's slow it down so we can see the impact of the acceleration vectors. Okay. Alright, and I'm going to put the component acceleration vectors there. Nice color-coded kind of things. Alright, now that is just looking at a couple of little ideas. And we're flinging a car around, and we've got like crazy diameter type things here. Now we've got some like drag or air resistance there. Now when we put the drag on there, it still hit the target, but you know it barely hit the target. Okay, now let's monkey with the angle here. Now this takes it and makes it like, oh my goodness, this is more than just what I would expect an Algebra 1 or an Algebra 2 student to be able to do. This would probably require parametric equations. And, you know, I don't know if I'd even cover that in my pre-calculus course. But it's cool to play around with. And you can see that you actually get that parabolic shape. And bare minimum, you get a good parabola problem out of that deal. Now, there's a lot of like, oh, don't worry about that kid discussion when they ask you the hard questions about physics. Or you get to like tell them everybody's favorite, like, you're not ready for that yet. That kind of thing. You could ask things like, when would it be at its highest point? If I don't change anything but the angle of inclination, how are we going to get to that particular, are we going to be able to hit that target? And I don't know. I think it's a really cool application that like you can use it to discuss lots of different math ideas. Now you may not be able to get a kid to be able to understand the actual whole picture, but you could build functions to model the duration of the flight. There's lots of cool things you can do, and the fact that you can put those component vectors on there, and you can fling a ridiculous amount of things. Now here's might be where, well, okay, I changed what I'm shooting. Is it going to hit the same spot even though I've changed what I'm shooting? And it's a little bit different of a trajectory, but it does hit it. Tank shell's kind of boring. Let's see what happens when we shoot a human at that. All right, let's see if the human makes it. Okay, there's my dude climbing up and down. It appears that he's going to land right where he needs to. All right, lots of potential for lots of math problem in that. You know, not one particular game. I guess it's a game to get the star there, but it's got a lot of potential to be able to be diversified. You can even change the height of this thing. I didn't even mess around with that, but I can change that, and then that changed the ball game quite a bit. Okay, and you could have the discussion like, did changing the height change the trajectory? Did he miss his target? And he missed his target by a little bit. So I'd either have to juice my angle of inclination, or I'd have to juice my like initial speed, or you could pose the question about which one makes more sense. And then you could do this thing. You could say, okay, well, I'm going to go 1 meter per second more. And does he make it, or does he miss it? And it's pretty close. It looks like he's going to hit it, but he's on the boundary. And then maybe I take it back to the 16 and say, well, okay, well, what if I would have changed the degrees 5 degrees? Now, there are some limitations to this program. A 5% inclination change, you could just say, well, that's what the candy manufacturer said. So in this case, was that 5 degrees going to be enough, too much, just enough? Is he going to miss the target? Now he got it, but there's only one star. So I guess in that context of a game, since we didn't hit the dead center of it, we only got one star. Okay, but repeated iterations, trial and error, all things that game theory or gamification was talking about. Okay, that's just within the intro program. All right, if we take a look at this vector thing here, and like it's got this cannon, and I like it because it actually puts like the projectile level like below. It actually puts the machination on below, and you're assuming that this person's like standing right at ground level. That's a nice thing. Okay, because this like little like stand here is actually above the ground. Okay, so let's see what vectors had to do with that. And I don't know. They're giving us only one option. They're saying a diameter of a cannonball, and let's make it a really heavy cannonball. Let's maximize its weight at 10G, and I don't know. Let's see the component vectors and see what happens there. Okay, and it appears I crushed and killed my guy, or at least took his pants off. I don't know if that's pretty lewd that he's taking his pants off, but that's fine. Alright, let's shoot it again, but this time let's put all the component vectors on, or just the velocity vector. Alright, so this time I missed. Oh, it's because I reset the mass. Okay, if I put the mass at 10, then you can see, okay, this has got two different types of velocities. It's got a horizontal velocity and it's got a vertical velocity. Okay, and that's a good thing that you can kind of show that, you know, gravity does have its impact as well as the inclination. Now the inclination discussion I just probably wouldn't get into. I lack the physics behind what I need to know to actually describe that. But it's good to know it's out there. Once again, you could talk about this in discussion of a parabolic shape. You could say the path of this projectile will follow this particular quadratic model, with this being 0 and like this is how far away it is. And then you can just like throw this variable in there. It's like if it has an angle of 75, maybe you look and study and see if there's some way that you can connect the three variable model in respect to the angle. But in math, as soon as you start throwing a third variable in there, I mean, your life gets to be a lot harder. Okay, it's nice that it's consistently hitting the same spot. Okay, not looking like we're getting real close there, so I'm going to shoot it at 70. And then 70, look, is the winner. I get the 3 stars. Now, I'm going to put it at 65 and see if I miss it on purpose. And I do. Okay, so you could talk about family of functions here. There's lots of potential, and you can measure how far apart from the vertex it is. This is just an excellent like method of having math conversations. All right, thank you for watching my video.